Another way of thinking about AI is as an agent. The concept of AI as agent is that the computer has its own ability to do things and to make choices and to help you, much like a personal agent would. And in fact, right, we often think of people that are successful in the world, that are very efficient, have people, whether they're executive secretaries or some other kind of person, that can help them do their job well. So the idea is, if we could have a really good computer program, wouldn't it be nice if a computer program could be an agent to help us do our work? And there is a whole line of AI researchers that for decades have been pursuing this. Let's just take a very quick look at this video segment. It's a few years old, but it shows one vision of what an agent might look like.
Well, we want to take the technologies that allow the computer to be a bit more like people. People, see and touch and hear and speak, and we've really only done a very little job in making the computer deal with those, and usually only one at a time. We might add a handwriting input or a speech input, but people don't use those senses only one at a time.
That's fantastic.
Hi, my name is Laura, and today I'm here to help the receptionist with shuttle reservations. What's your name?
I'm Dan, and this is Eric.
Nice to meet you. Do you need a shuttle?
Yes.
Which building are you going to?
I forget, where are we going?
And so the demo I showed this morning, which was a prototype of a robotic receptionist that might sit in our lobby and schedule shuttle visits for people from one building to the next, was an attempt to bring together 3D graphics and modeling and animation and speech recognition and image processing in order to create a more natural interaction between people and the computer. And I think it does a pretty effective job at showing that we're really at the cusp now of being able to have the computer have a more integrated humanistic relationship to the people that want to get things done.
This idea of AI as agent, it turns out, is quite controversial. And it's been an ongoing controversy for a number of years. And the essential reason is because the people that like computers to be in control, to have agents that make decisions, will have the feeling that if only the computers would be good enough at doing that, they would have the ability to save humans a huge amount of effort in decision making. Right? The agents have the ability to deal with much more complex information. Right? The person has the potential for delegating responsibility to that agent and not have to worry about it anymore. On the other hand, there are people, notably user interface people, HCI people, like my colleague here at Maryland, Ben Schneiderman, who has argued for a very long time that that's actually a very bad idea, and that the person, the human, must stay in control of the computer at all times. There's lots of reasons for this, but a big part of it is that if the computer isn't predictable, if the person doesn't know what the computer is going to do, if the person loses responsibility because the computer is doing things, then the person is going to be very unsatisfied. It's going to not feel like it's their life. They're going to have to give up, right, the ability to really be able to understand and to know and to control what is going on, and it will result in an unsatisfying experience. And practically speaking, until agents have very, very, very high quality performance, then it gets very frustrating. In fact, we can see this just in a simple issue related to text entry on a mobile phone, right? When Apple introduced autocorrect on iPhone, the goal was to make it more efficient to type because most of the time it autocorrected correctly. But we all know that it makes enough mistakes that it can be incredibly frustrating. And even if it's 99% correct, if you want to have really high quality output, typing, and you don't occasionally want to say things that are totally ridiculous, then you have to proofread every single thing that you write. And that proofreading, to take back control from the computer, can be very frustrating. So much so that many, many people find that 99% textual automatic correction is not sufficient. So just imagine if we're not willing to give up control at that level. Would we be willing to give up control to have a computer agent automatically make flight reservations for us? or decide when to pick up our daughter from school, or something of much higher import. So in the end, the way that the current industry, right, computer industry, has been settling is that the user tends to be in control of the user interface, of the actual thing that's going on. And then under the hood, there is AI doing all kinds of complex things, making suggestions, making best guesses, right, making it efficient for the user to choose what actually happens, but not typically for the computer to go ahead and make actions and choices for us. At least not yet, until the computers are much, much better. And even so, it's not clear when people will want to make that trade-off. A side note of this is it a good idea to design systems that have anthropomorphication? That is, have the computer systems look and behave and talk as if they're humans? Or should they look and behave and talk as if they're computers? A lot of computer scientists think it's fun to have computer systems that look and behave and talk like people. But the market has shown over and over and over again that most consumers don't like that. And a simple example is your car. When it became cheap enough and possible, now almost 20 years ago, for your car to talk to you, then there were some experiments that when you opened the car, it would say, car door open, right? The car would be talking to you. But it turned out that was so annoying because everybody knows the car is not a person. It talked in monotonous, repetitive ways, and instead what people like is a simple chime or some kind of important feedback that lets you know the car is open without pretending that it's a person. The list of places that advanced algorithms that we can think of sometimes as AI that exist in our lives and in our computers, in our consumer experience, is all over. I'm not going to go through all of them, but right, yet another one is personalization. Collaborative filtering is a set of algorithms that were developed over the last couple decades that make it possible for Amazon to tell you what you might like. It turns out that makes Amazon a lot of money. People tend to like it because there's adaptive processing going on in the back, but it's entirely up to the user's control. A more recent one a few years ago is when Gmail gave an option to warn you that even though you sent email to John, it wasn't the John you normally send email to when you send email to someone else, so it asked you, did you mean this other John? Right? These are all examples of adaptive AI that fit into the user experience that tends to work quite well. We all know that AI at this point can be useful, but is imperfect. We've talked about the example of text entry. Another example is translation, right? Google's Translate is world-class. It works absolutely fantastically. But even on fairly simple examples on common languages, it makes significant mistakes. Go to translate.google.com and type in a sentence to translate it from English to another language, and then translate it back from that language back to English, and you will find out that it regularly makes mistakes, sometimes substantial ones. And that simple example, it indicates what kind of problems you might run into and just how hard it is to translate really well. I typed in the example, I am really hungry but don't like to eat meat, so can you help me find a suitable restaurant? Well, going into Spanish and back, it came up with, I have very hungry but I like to eat meat, so can you help me find a good restaurant? Well, in that case, the syntax was imperfect, but I think I could pretty well understand what the semantics were, what it meant. But I tried translating it into Bengali, a less common language where we have less data to train our systems, and then back to English, and this is what I got. I'm really hungry, but we can help you find a suitable restaurant that does not like to eat meat. Well, that's just weird. I mean, I'm guessing that it doesn't mean that the restaurant doesn't like to eat meat, but it requires some real effort to figure out what it probably really meant. So when do we decide whether AI is good enough? Well, from a commercial standpoint, the answer is, right, Google Translate already is good enough for people to choose to use it and for them to make money. But another way of thinking about whether AI is truly successful is whether our systems have gotten good enough so what the task is, whatever the task is indistinguishable from what a human could do. The first person that came up with this idea was Alan Turing in around 1950, and his test came to be known as the Turing test. The idea of the Turing test is that you take a person and you have them type into a terminal to ask anything that they want. And the thing that they're asking is either a computer or a person in another room typing through a terminal. And you don't know whether you're asking a computer or whether you're asking the person. And your goal is to distinguish whether the thing responding to you is a computer or a person. And if you do this test several times and you can't distinguish accurately, well, then the computer has passed the Turing test and has demonstrated intelligence. Another interesting example, thinking about intelligence, is John Searle's philosophical thought experiment called the Chinese Room. I want you to go look that up and see what you can figure out about it yourself. It's pretty interesting. And the last example is what's known as a chatterbot. A chatterbot is kind of an operationalized version of the Turing test. It's not actually trying to pretend to... It's not actually doing the experiment to distinguish between a computer and a person, but it is simply a computer program that takes whatever you type in and does its best to respond as a person. And they're typically implemented by looking at what lots of other people have typed in and use that to build up a database of possible responses to come up with a software robot that will respond. Go check cleverbot.com and have some fun playing with it. A couple of last things about AI. You should be familiar with the term singularity. The key idea of the singularity, popularized by Ray Kurzweil, is that once AI gets to be good enough, once it truly reaches the level of human intelligence, then the next level of AI programs will be designed by AI systems rather than by people. Well, if they're as good as people, then they'll be able to design AI systems as good as the ones that designed them. And those ones will be more intelligent. And then those ones will be able to design better AI systems, which will design better AI systems. And of course, they'll get better and better and better. And this is all happening at software speed. And so what we've got now is humans developing an AI system. And that takes a very long time. And it gets a little bit better, a little bit better. And so we just have a slow curve of improving AI. But then there's going to be, the idea is that there will be the singularity at which point AI systems will start designing AI and it will spiral out of control. And of course, the doomsayers say that is the beginning of the robot overlords and the end of humanity. The reality is that nobody knows whether the singularity will come and if it will come. Personally, many people, I would say most, including myself, don't think it's likely really to ever come, certainly not in the foreseeable future. And the reason is that despite Cleverbot and chatterbots, the reality is that humans are so vastly far superior to what computers can do and do things on such a richer way that we cannot even conceive of how we can get there. It is absolutely true that computers can do certain tasks incredibly well. Remember how we started. Any program that is good enough that it can be useful and seems like AI, well, it's not really AI, it's just software. So we have to decide whether we as people really do something differently, fundamentally, than what computers are able to. The answer so far, in my view, is yes. Finally, I'll end with a fun note. If you haven't read Isaac Asimov and want a really fun read, go read I, Robot. It was one of the earliest really popular robot science fiction movies, science fiction books. And it starts with these three crucial laws of robotics, where they built into the positronic brain of these robots these three rules which would ensure that even if there was a singularity, that we as humans would still stay in control.